Welcome everybody to Calculus BC. In today's episode, we're going to be continuing our adventure through chapter 9.8, which is the radius and interval of convergence of a power series. And so basically, when it comes to a radius or an interval of convergence, what they both deal with, radius and interval of convergence, they both deal with how much the polynomial will resemble the function it is supposed to. And so in the last episode, we learned about how a power series is a polynomial that is used to represent a non-polynomial function. And so in this case, the radius of convergence, is how far out from the center will the resemblance happen. And the interval of convergence, and not to put to convergence, and this is kind of a pretty direct definition here, but basically what it is it's the interval in which the resemblance happens. Okay, so let's see how this plays out here. If I give to you a series that looks like this, from n equals 0 to infinity of negative 1 to the n times x to the 2n plus 1 over 2n plus 1. The question will be, for which values of x will the series converge? So again, they'll ask me to find an interval of convergence for which the function is going to converge, and I have to figure out the value of x at which this is going to happen. So the reason why we learned all these different convergence tests is so that we could figure out for which values of x will make this series resemble the polynomial it's supposed to resemble. So which test seems most appropriate here? I don't think it's going to be the alternating series test because the x needs to be an actual number for that. But I think because we've got some annoying exponents going on up in here, we've got the ratio test at hand. So I feel like I'm going to do the limit as n goes to infinity of x to the 2 parentheses n plus 1 over 2n plus 1 times 2n plus 1 over x to the 2n plus 1. So what's this going to become here? Well, what I've got here is if I simplify that out, I get 2n plus 3. That becomes 2n plus 3. So in the next step down, I've got the limit as n goes to infinity of x to the 2n times x cubed over 2n plus 3 times x to the, times 2n plus 1 over x to the 2n times x. And these are all an absolute value right here. So what's going to happen? Well, what I've got is I've got the x to the 2n's going away. I've got the x cubed and the x kind of going away, leaving me with x squared. And what that gives me is the limit as n goes to infinity of 2n plus 1 over 2n plus 3 times x squared. Now, it's important to note that this is the limit as n goes to infinity, which means x is pretty much a constant right here. It's a non-variable, which means this guy ultimately goes to 1, and I end up with just the absolute value of x squared. Now, of course, the ratio test is contingent upon the inside totaling out to become less than 1. So in order for this thing to converge, the absolute value of x squared will actually have to be less than 1 in this case, which means the radius of convergence, that's what this guy is, so this is the radius of convergence. But my interval of convergence will be x being between negative 1 and 1. Now the question is am I actually convergent or divergent at the extreme endpoints? Well, the way I'm going to find that out is I'm actually going to plug in 1 and -1 into the original series. So at x equals -1, what I've got is the series from n equals 0 to infinity of -1 to the n as my alternator, but I'm not going to put it in x anymore. I'm going to put in a -1, and he's going to be raised to the 2n plus 1 over 2n plus 1. Now, these guys can multiply out. What I can get is I can get the summation from n equals 0 to infinity of -1 to the 3n plus 1 over 2n plus 1. Now, if n equals 0, I'm going to end up with 1 here, which is going to be an odd number, so that negative is going to survive. If n is 1, I'm going to end up with 3 plus 1, which is 4. That'll end up being an even number here, giving me a positive value. So this series does alternate here, which means I can say that a sub n is decreasing. The limit as n goes to infinity of, looks like 1 over 2n plus 1. Again, I'm doing this without the alternator. That equals 0. So I can say, therefore, by AST, or the alternating series test, the sum from n equals 0 to infinity of -1 to the 3n plus 1 over 2n plus 1 converges. And that allows me to say that we are convergent at that point in time. So I put an equal sign underneath there. So then at x equals 1, we have the sum from n equals 0 to infinity of -1 to the n times, in this case, 1 to the 2n plus 1 over 2n plus 1. Well, 1 to the 2n plus 1 is just going to be 1, right? So that's going to be n equals 0 to infinity of -1 to the n times 1 over 2n plus 1. Another alternating series. So a sub n is decreasing, and the limit as n goes to infinity of 1 over 2n plus 1, in fact, equals 0. So by alternating series test, the series from n equals 0 to infinity of, looks like, -1 to the n over 2n plus 1 converges also, which allows me to then put another equal to sign underneath that right there. So my interval of convergence is from -1 to 1, with -1 and 1 being included. Hopefully that makes sense. I'll be back with the next example. All right, in this next example here, I'm going to go and find the radius and interval of convergence again. So, again, lots of annoying exponents and stuff right here. So I feel like the ratio test really is going to be kind of our thing to go to. So that's going to be -3 to the n plus 1 times x to the n plus 1 over rad n plus 2. Multiplied by rad n plus 1 over -3 to the n times x to the n. So now what I've got is I'm going to go ahead and expand this guy out. So I'm going to go ahead and say the limit as n goes to infinity of, looks like -3 to the n times -3 times, I'll go and say x to the n times x over rad n plus 2 times rad n plus 1 over -3 to the n times x to the n. Let's see what gets out of here. I'm going to go ahead and cancel out the -3's here, cancel out the x's, and what I end up with here is the limit as n goes to infinity of, looks like, -3x times, and since these guys are under the same radical, I'll just go ahead and put them all underneath one big hunkin' square root right here. And as n goes to infinity, this guy here goes to 1, giving me the absolute value of -3x, or just absolute value of 3x, and that's got to be less than 1. So now from here, what I've got is I've got x, my absolute value here, being less than 1/3. So 1/3 is my radius of convergence. So that means that my interval is going to be from -1/3 to 1/3. And again, the question is what type of inequality am I going to slam down on this thing? Well, let's go and find out. I'll go and do at x equals -1/3. Well, what's that going to give me? Well, that's going to give me the sum from n equals 0 to infinity of negative 3 to the n times negative 1/3 to the n over n plus 1 underneath the radical. So from here, they both have the same exponent. So I can go and cancel out the negatives and cancel out the 3's. So what I end up with is the sum from, whoa, that was weird, from n equals 0 to infinity of 1, really, over n plus 1 underneath the radical. So from here, how do I figure out if this guy converges or diverges? Let's go ahead and do limit comparison on this thing. I'm going to compare him to the sum from n equals, say, 1 to infinity of 1 over root n divergent p series. P equals 1/2. So now I'm going to say the limit as n goes to infinity of 1 over root n plus 1 times root n over 1. Well, that equals 1, which is positive and finite. Therefore, by limit comparison, the sum from n equals 0 to infinity of 1 over root n plus 1 diverges. Which means I do not put anything underneath this bracket right here. So let's go ahead and see what happens at x equals positive 1/3. So that's going to be the sum from n equals 0 to infinity of negative 3 to the n times, that's an n, 1/3 to the n over root n plus 1. Well, those guys are going to cancel, and I end up with negative 1 to the n over root n plus 1. Well, that looks like an alternating series right there, in which case I can say a sub n is decreasing. The limit as n goes to infinity of 1 over root n plus 1 equals 0. So this guy is convergent by alternating series, right? So the sum from n equals 0 to infinity of negative 1 to the n over root n plus 1 converges by AST. So we've got divergent on one end, convergent on the other, which means this is going to look like this. And that is our interval of convergence for this particular question. Hopefully that makes enough sense. Go ahead and please leave comments or questions in the comments area. I will see you all in the next episode.